someone has implemented the RSA algorithm and you can simply use it. Here you can and now I want the message. This is my message. As you know, I copy public key, I paste it here. This is my message. Hello, this is the public key, and my algorithms are and encrypt now. This is 64 format, and decryption we should use the private key. So I copy the private key, paste. I choose the okay. Python for programming, encryption, decryption, and digital signature. Okay. Did you? This is okay. For using in Python libraries in course. From cryptography has backend RSA library from cryptography primitives asymmetry, and we need to import serialization. Before starting, let me explain what is serialization. Who knows what is object serialization? Object serialization. We need them also in the exam, but I don't ask you to implement some programs. Just I will ask you to use these libraries, okay? For example, I will ask all of you to create, with today's programs, I will give you some programs today. I will ask you to create public and private key. Then I will ask you to share the public key, but keep the private key safe, okay? Maybe and encrypted your public key and ask, okay, now send me what was the main text. In fact, decrypted message, complicated programs. Okay, what's object serialization? Who knows? Nobody? Suppose that you have a class. For example, class student. As you know, each class has some attributes, which may be private or public, but We don't care it's private or public. Yes, exactly, Zainab. Yeah, your answer is completely right. Okay, suppose that each student has an ID, average. When I define an object, for example, say student X. Okay, X is a student. If I want to print X, X is just a variable and has an address in the memory. But if I want to print object or I want to exit, serialization means converting the data associated with an object to series of bits, sequence of bits. Okay, this is called serialization, converting an object to a sequence of bits. In fact, part, not the methods, not the functions, only the data part is converted to a sequence of. So suppose that I'm running a program now. I have many objects, but I want to before that I can serialize the objects. I can store them in a file. Then in another program, for example, tomorrow, again, I can open those files and read those objects from that file and continue the program from the point that yesterday was a stop. Okay, so let's back to the Jupyter. Okay, so we need just these three libraries. What say in this lecture I to show you how to create a private key, how to encrypt a message, digital signatures, and how to verify digital signatures. That's it. Okay. If you watched previous lecture, what's encryption, what's decryption, and what is digital a message using key encryption. If we decrypt, but if we encrypt a message key, it's called digital signature. Encrypting a message using private key is called digital signature. And let's see the program. In this command, RSA private key, you can simply create a private key, but it's an, please note, this private key is an object using this command, RSA generate private key. There are some parameters. Each value may result in a different private key. The key size here is 2048. You can use 510 or larger or smaller key size in third backend. Okay, so just this function, it These three parts, you will have an object. This is private key. Now, to see what's the private key, we should know. I want to print out the private key. Okay, to do so. This is the object private key dot bytes. Using command, I want to convert the private key to a printable format. Encoding, serialization, encoding. There are two formats for representing. Please note, there are two formats for private and ER. What's the difference? That format, this private byte has three parameters. Encoding, you can use either serialization encoding .pem or serialization encoding .der. Okay, you can use one of these two values. Then the second one is the format. Description. Here we are saying that no encryption. You can put password or private key. Here I don't do this. Okay, so here I have a private key with the password. To generate the public key, private key that now is an object. I create a file with example rsa key.pem. Write binary private key private by exactly command print. Here have saved the private key into file rsa key.pem. Then I have printed the public key using this command. Public key, as I said, public key is an object. This command serializes this public key. Encoding serials, encoding PEM. Format is this. Here I have saved the key into a frame RSA pub.pem. I run the program. Okay, you can see this is this private key and this is the public key. You can change some parts. For example, you can change the PM to DER. Okay, DER, DR, DR. As you can see, it's a sequence of bytes. DER, but the PEM more readable. PEM. So use PEM. 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 Yeah. Okay. Yes, it's very long. It must be long because each time you generate a private key, it must be a no two-person private and public key. It's very long. Usually, people save them into a file, copy it. we usually save it into a file, and when we need, we use the file. Okay, so here I save them into the file. RS is my private key and rs8pub.pm is my public key. This simple piece of code generates a private key and its associated public key. So to run this program on your computer, I ask you to run this piece of code on your computer. Keep safe the private key and share the public key Telegram group. Okay, share your public key into the Telegram group. So I will send some encrypt. Okay, run piece of code, save this file onto your computer. You need this file for encryption, and just share this file. This piece of programs, yeah, you need this piece of programs for the exam. Okay. So far we learned. Okay. Now let's encrypt some messages, and now I want this is the I don't send you the program. You just search, find these, okay, or are available from the net. So you can simply just search or computer, run it, and send the public key to the group. Now let's encrypt the message. For encrypting a message, we need these libraries, and in the previous I have used load pin private key and load pin public key because I want to load this format of the private and public key. For DER, you should import DER, private load DER. Okay. My plain text is something is hello world. I 1, 2, 3, everything. This I want to encrypt this message. Next, of course, I saved a file rs8pub.pm here. This is the public. Okay. So here, using this command, load pem public key, load pem public key, read the public key from and to Alice public key. So this public key now is an object, is a public key. Encryption, I use this Alice public key dot encrypt. So method encrypt from a public key encrypts a message. The parameters. The first one is the plain text. I want to encrypt this message, in fact. Okay, so this is here. It's a padding algorithm. This padding algorithm uses SHA-256. What search and out padding? It's not important. I want just to use this command for encryption. Okay. Now Now, after executing this command, this is cipher. This is the tree. Text, something like this is printed. Okay. Then now I want to encrypt the message. For the encryption, I need the private key. So again, I open the file which contains my private key. I read my private key using this command, serialization load pen private key. So Alice private key now is the object of the private key. Using this command, Alice private key dot decrypt, and the parameter ciphertext, again the padding algorithm. I decrypt the message. So D now is the decrypted message. Here I have printed the encrypted message. So this is the main message. If I run the program, this is the encrypted message, and this is decrypted message. Everything here. Message. So using this piece of code, you can simply encrypt and decrypt. Integer, there is no algorithm. Some parts, for example, you can change the text for encryption, but for encrypting, you must call this function a public key encrypt. Okay, so you can't. Oh yeah. Yes, you can change. You can change to 5.6, for example, with SHA-1. Yeah, you can. But if you do this, you change this part. For decryption also, you must change this part. Okay. So RSA, this is RSA. Okay, RSA is using SHA-256. Okay, here, as you can see, for decryption and here for encryption, RSA needs a hash algorithm. Here we are using SHA-256, but it can be another hash algorithm. Okay, this program this is the same as the above. This is nothing. Here is exactly the same program, but using a password. Using a password, you put a password for your private key. It's very important. If some have access to your private key, so can encrypt all your messages. So it's very important to keep very safe the private key. So you can define a password for your messages. Okay, now let me check. This is load. Okay. This part of the algorithm is as the same before, but when I'm trying to save the private key, this part, see this part? I put password 1, 2 in the previous here, encryption algorithm serialization dot no encryption. Okay. Private key, private bytes, no encryption. But here private key, private bytes, you can use algorithm serialization 1, 2. So want load the private key from a file, you should use this password here. When you load the private key, you must. And finally, I want to create a signature. What's a signature? Signature digital is when you want your money sign your transaction. Suppose that containing one coin, containing the address of sender, containing the address there. Also, digital signatures prove that this is Bob, and no other person can spend Bob's money. Next week, I will be talking about blockchain, transactions, blocks, and everything, okay? But for now, I just concept use we want to talk about blockchains, blocks, transactions, and blockchain technology. So for creating a digital signature, suppose that I have a message. I want to sign this message. How to sign a signature? For signing a message, my private, all others have my public, so they can simply check it. If everything is okay, it means that really was sent by me. Okay, so as I said, digital signature is used to is used for authentication. Okay, consider a message. For example, a message I want to sign. The signature private key object. This is a private key object. Alice private key. This is Alice private key here. Okay, I have load a private key here. So this is a private key object. The method sign generates a digital signature. This function takes 3 inputs. The first one is the message. This is message, the message we want to sign. Okay. And finally, a hash algorithm. For this case, if I run the program, this is the signature. This is the digital signature. Please note, every time I run, this will change. You know, maybe you say, oh, what happens? The message is the same, but the digital signature is changing. In fact, digital signatures used once. Digital signatures are used once. It's not important. It's important that digital signatures can be verified. So I have created digital signature. Now I want to verify this piece of code, verify a digital signature. Here, signature, let me copy, paste. Okay, so using this command, I converted this hexadecimal string to its equivalent in the byte format. Main to sign, okay, like this. And now for the verification, I use the object public key. Public key is equal to Alice private. Verify its parameters: signature, the message, padding, and hashes. Okay, I run the program. Okay, nothing happened. But if I change, just I want to change, for example, the first character to, for example, and now there's an error, invalid signature. It means that this, if I change now, everything is now. If I change the this message, for example, I just a space at the end of it, just a space. Okay, if I run the invalid signature. Okay. About padding, these algorithms work on different sizes inputs. Okay, different sizes inputs. Before converting, input must be in padding means that putting something extra at the end of the message to resize the message to a size. There are different algorithms, and using different algorithms results different outputs. So, for example, if you encrypt a message with my program, with this program, can't decrypt it line websites. Or if you encrypt a message using the first website, you can decrypt it with the second website because these padding algorithms are different. You can search and learn more about padding, but we don't need these details. We just use these concepts for the blockchain technology. Okay, I will send you the program. Don't worry. Even though you can simply search the web and you can find these simple comments. So this is the digital signature. What's the application of digital signature? It's very important. Please note. Digital signature for key. For signing a digital signature, I use my private key. To verify, the others use my public key. So if everything is okay when verified, it means that this is my message. This is not fake. Okay. Put different signatures. Same. See this? Okay. And this is this part public key, this part encryption, this part decryption, encryption, this part signing a message, this part verifying the message. Okay. Very good. So I will send you the program. You can simply run it. You can input messages, encrypt, decrypt, different messages. Even you can share public key, not private, just you can share public key, send to each other some encrypted messages. So you can talk with each other using encrypted messages. Nobody can see what you are telling to each other. For example, in the Telegram group, I will, after your public key, I will send some encrypted messages, and just one person can decrypt the message, and just one person can read my message, even though all person in the group will receive the encrypted message, but nobody can decrypt the message, just one person. And which person? The person who has the private key associated with the public key that I used for the encryption. Again, these digital signatures used for authentication. Everybody can find this message because I use my private key for this message. In fact, this is an encryption of a message with my private key. Since others have my public key, so all others will know what is the main message. The application is that this proves that it's me, and this is my it's my digital signature. In contrast, signature, as you can see, every time digital signature is something different. I think I talked about this in the previous lecture, but again, real signatures or hard signatures always are the same, but digital signatures every time will be changed. Okay. So if you don't have any question, let me back to the blackboard. No question about this? We use another encryption called or C. Okay, A is not used in cryptocurrencies like Bitcoin. Instead, another algorithm called elliptic curve is used. Elliptic curve is something like this. Please try to learn these concepts, and now don't think about the exams, just please concentrate on learning these simple concepts. Okay, as I said, in Bitcoins, another algorithm called elliptic curve is used, and not RSA, but when we want in a cryptocurrency like Bitcoin, when you, for example, Bob sends some, if Bob wants to send some Bitcoin to Alice, Bob must have Alice's public key. Okay, public key. So Bob creates a transaction including Alice's public key. In fact, encrypts it with the Alice public key. And who can unlock this transaction? The only person can unlock this transaction is the person that has the private key, and that's Alice. Okay, but in Bitcoin and other cryptocurrencies, we don't use public keys. We use addresses, wallet addresses. What's a wallet address? A wallet address is the hash of a public key. So every person in the, for example, Bitcoin has an address. In fact, the address is equal to, for example, SHA-256 of the public key. Okay. So please note, in all cryptocurrencies, the addresses are the hashes of public keys, and people are using these addresses to send and receive monies to each other. Okay, and it doesn't matter that we use RSA or elliptic curve algorithm. Even though, as I said, we use elliptic curve, but the general concept is the same for both algorithms. The address is the hashes of public key. Okay, so in next lecture, I will talk about elliptic curve algorithm. Elliptic curve. This is another approach for generating public key, private key, encryption, decryption, and creating digital signatures. Also, I will show you the associated libraries in Python for elliptic curve. The commands are very similar to the RSA. There are some differences in the details just, okay? What's elliptic curve? As I said, elliptic curve is something like this. And this is the general equation of the elliptic curve. Y to the power 2 equals to x to the power 3 plus ax plus b. In Bitcoin, the equation which is used is y2 equals x to the power of 3 plus 7. How someone use elliptic curve for generating public key, private key? As you saw in the RSA algorithm, someone chooses two large prime numbers, P, Q, and you know what's the RSA algorithm. But what about elliptic curve? Before talking about how private and public keys are generated in the elliptic curve, we should define an operation plus the points onto this curve. There P, Q, B, two different points on this curve. Then P plus Q is calculated by this approach. We draw a line just let's consider another one. P, Q. For calculating, I'm defining a new operand called plus. I want to show you how to calculate P plus Q. We should draw a line from P to the Q, and suppose it cut the curve in another point like R. If we find the reverse of R here, this is P plus Q. It's an algorithm for encryption decryption. Yes, it's something like RSA, but in a different way. Okay, so as I said, we have an elliptic curve. I'm defining the plus operator. In some books uses dot operator. What's meaning? As I said, P and Q are both two points on the curve. To calculate P plus Q or P dot Q, we must draw a line from P to the Q. The third point, the reverse or the third point shows the P plus Q or P dot Q. But if this is P, this is Q, what happened in this case? What is P plus Q? In this case, this line doesn't cut the curve. We define a symbol 0 means infinity. So in this case, P plus Q equals to 0. As you can see, P plus Q is equal to Q plus P, or P plus Q plus R equal P plus Q plus P. It means that this operator on the nodes on the curve make a group, an abelian group, okay? But it's not important. The only thing that here is very important is we should know how to calculate P plus Q. Now let me know how to calculate P plus P, or in fact P dot P. Suppose that this is P. Okay. For calculating P dot P, we draw a tangent line. Here is green. This is the x-axis. This is P dot P. So using these approaches, you can find the result of such an operator on two nodes. These two nodes can be different or can be the same. Next week I will talk about details of the elliptic curve. Just here I gave you some explanation about this operator on the elliptic curve. In the next lecture I will talk about elliptic curve cryptographic algorithm. Okay, thank you all. If there's any question you can ask, otherwise next week I will complete this topic. Okay, thank you all. Good night.